Welcome to ScaleUp University. Welcome to the course on building applications with AI agents. So this is the lecture number 4 of module 2. And in this lecture, we will be discussing tools, the action layer of agents. So tools are the action layer of agents, and we will discuss tools in detail in this lecture. So if we look at exactly what all topics we will cover in this lecture, so in this lecture, we'll talk about why tools matter, what a tool is in agent systems, turning APIs into callable agent tools, designing tool interfaces, input validation, structured outputs, tool naming and schema clarity, tool reliability considerations, designing for safe execution, narrow tools versus general tools, tool granularity decisions, designing capabilities for specific tasks, tool design anti-patterns. So we will discuss all these topics one by one in this lecture itself. So this is the module 2, designing agent systems, lecture 4, tools, the action layer of agents. And we are starting with the first topic, why tools matter. So why tools matter? So see, if we talk about agents, they are different from chatbots. So chatbots, they generate text. See, we all have used chatbots like ChatGPT, Google Gemini. You ask it any question, it will give a response. So chatbots can only generate text. But if we talk about agents, agents can take actions. Agents can take actions. And how agents can take actions? Through tools. So agents basically, they will not only do the planning or make the strategy, rather they can also execute the strategy. They can take actions. So those are the agents. And how they take actions? Using the tools. So tools are the mechanism that connects the language reasoning to the real world execution. So tools are the mechanism that connects the language reasoning to the real world execution. Because without tools, agents, they can only suggest. They cannot take actions. They can only suggest. Agents cannot act. But with tools, using tools, agents can perform actions. Like agents can update databases, they can send emails, they can execute workflows, they can trigger APIs, and they can modify the system state. So that's how tools add value. So tools, they transform intelligence into capability. Tools transform intelligence into capability. Because see, if we talk about chatbot, it is just intelligence because it cannot act. But agents, they can also act. So tools, what it can do, it can transform intelligence into capabilities wherein agents now they can act, they can perform the real world execution. What a tool is in agent systems. So now let's understand what a tool is in agent systems. So in agent systems, if we talk about tools, so in agent systems, a tool is a callable capability that performs a structured action. A callable capability that performs a structured action. A tool is a callable capability that performs a structured action. A tool can be called by the large language model, and when the tool is called, it will perform some actions. So that is a tool. A tool typically accepts structured parameters. So tools, they accept the structured parameters they execute a deterministic operation and they returns the structured results. So tools, they accept the structured parameters, they execute a deterministic operation and they return the structured response, structured results. So that is what a tool is. Because the large language model, it will call the tool. In order to call the tool, it will pass some structured parameters. Then once the tool is called, it will perform some structured actions, some deterministic operations, and it will return a structured result back to the LLM. Then LLM will decide what next needs to be done. If we look at some examples of tools, so cancel order, and it is taking a order ID as parameter. Issue refund, it is taking two parameters, order ID and reason. Schedule meeting, it is taking two parameters, date and participants. And retrieve customer profile, it is taking one parameter, customer ID. So these are the examples of a tool. So tools, they take, they accept structured parameters, they execute deterministic operation, and they return the structured results. Now, one very important point to consider, a tool is not a prompt. A tool is not a prompt. A tool is very different from a prompt. A tool is not a prompt. A tool is not a conversation template. Neither a tool is a general suggestion. Because see, what is a prompt? Prompt is something which we give to the LLM, and LLM will process the prompt and generate the result. So processing will be done by the LLM. So a tool is an external entity. So whenever a tool is called, it will process. A tool will get executed, and a tool has, when the tool is executing, it has nothing to do with the LLM. A tool will run in isolation. So that's why a tool is very different from a prompt. A tool is a separate entity. It is a callable capability that performs a structured action. But a prompt is a text, or a command, or an instruction, set of instructions which you give to the large language model. So a tool, a prompt is very different from a tool. So a tool is not a prompt. A tool is not a conversation template, and a tool is not a general suggestion. So tool is basically a defined action boundary. Defined action boundary between agent reasoning and system execution. So see, what happens is that large language model is the intelligence component of an agent. So large language model, it will do the planning, it will make the strategy, how to execute a task, and the execution will be taken care by the tool. The tool is different from large language model. So a tool is a boundary, it's an action boundary between the agent reasoning and the system execution, wherein the agent, the LLM, large language model, it will do the planning, it will make strategies, and tools will execute. So system execution. Turning APIs into callable agent tools. So if we talk about turning APIs into callable agent tools, so see, APIs are different from tools. So this is a very important point. So most tools, they wrap business APIs. So tools are different from APIs. So tools, what they do, they wrap business APIs. They wrap many business APIs. So tools, they wrap business APIs. APIs are not agent ready by default. So the idea is that agents should not directly hit the APIs. They should not directly interact with the APIs. Rather, they should interact with the tools. And what are tools? Tools, they wrap APIs. The reason for that is APIs, they are not agent ready by default. So that's why what we should do is that, let us suppose you have several APIs. Now, based on the capabilities, you decide the tools and wrap those APIs on that tools, and then your LLM should call those tools based on the requirements. So that is what turning APIs into callable agent tools is. Let us take an example. Like let us suppose we have a raw API. We have a raw API. The endpoint is this. It's a post request version 3 orders refund. So this is the API endpoint. Order ID, reason code, metadata. Order ID, reason code. So these are some parameters for this APIs. So it will take these parameters. So this is the API. So now what we should do is that this is a raw API. Agent should not directly interact with this raw API. This raw API is not agent ready by default. Rather, we should create a agent friendly tool for this API. And tool is basically intent based. So when we create a tool, what we have to take care of is first we should specify a name for the tool. Like we are creating a agent friendly tool. So the name of the tool is issue refund. Description: issues a refund for a customer order. And parameters: order ID, reason. So we created an agent friendly tool with a name of the tool, that is issue refund. Description is very important. Description tells us that what that tool is about. So this tool issue refund is about, this tool issues a refund for a customer order, and the parameters which this tool can take is order ID and the reason for refund. So how we translate the raw API into agent friendly tool? Let us understand that. So we have abstract away version numbers. So all the version numbers we should remove while creating the agent friendly tool. Internal metadata we should remove, and we should remove the backend implementation details. So now it's very clear that whatever raw API we have, the version numbers of that API, the internal metadata, backend implementation detail, all that we should remove. And the remaining part, like the name, the description, and the parameters. So these three things we need when we design a agent friendly tool. And with this process, like once we have agent friendly tool, like whatever translation we are doing from the raw API to agent friendly tool, what benefit we are getting is it is simplifying the tool selection. It simplifies the tool selection. It reduces the hallucination, because unnecessary information will create hallucination. It increases the reliability, because once we got away with the version number, once we got away with the version number, so now our tool is more reliable, because versions it keep on upgrading, but with tool those issues will not be there. So this abstraction, this translation, it increases the reliability, it improves the maintainability. So this translation, it simplifies the tool selection, it reduces the hallucination, it increases the reliability, it improves the maintainability. So agents should call tools designed for intent, not raw endpoints. Now this is a very important point. So see, the idea is that until now, when we design APIs, we design lots of APIs. And the goal for API is to give access to some resources. But when we are designing agent friendly tools, the goal should be the intent. So the tools should be intent based. Like what are the possible intents? And based on those intents, we should design the tools, and those tools should wrap APIs. Those tools should wrap business APIs. And in this way, we should design the agent friendly tools. So agent friendly tools are intent based. So first we should identify all the possible intents for that particular use case. And for those intents, we have to design tools. And for every tool, we should wrap the corresponding business APIs. And in this way, we should turn APIs into callable agent tools. Designing tool interfaces. Now let us look at designing tool interfaces. So how we can design the tool interfaces? So well designed interface, if we talk about well designed interface, it has clear purpose, minimal required parameters, explicit parameter types, deterministic behavior, and predictable output format. So now the idea, now we are seeing that how we should design the tools. So when you are designing the agent friendly tools, the most important thing is the intent. What intent that tool is about. So the purpose of that tool, clear purpose. So whenever we are designing the tool, the purpose has to be clear. Like what, for what purpose that tool is. So clear purpose, minimal required parameters. So whatever parameters we are passing to those to that tool, we should avoid unnecessary parameters, minimal required parameters, and along with that we have to specify the data types also of the parameter. We call it explicit parameter types. Explicit parameter types. And the tool should be deterministic, like with the same input and the same conditions, the response of the tool has to be same. So that we call it deterministic behavior. And predictable output format. So the output format should be structured, it should be predictable. If we look at an example of a poor interface example, so here we are talking about a tool named process request, and it is taking one parameter data blob. Now this data blob, the name is in itself is vague, and what kind of data, what output it will generate, no parameter type is specified. So if we look at this example of a tool process request, it is taking one parameter, but no parameter types are specified, and what parameter it is taking, it's very vague. On the other hand, if we talk about good interface example, update shipping address, update shipping address. It's a good example of a good tool, because here we are specifying the parameter type also, like the string. So name of the parameter and the parameter type, name of the parameter and parameter type. So we are specifying the parameter type also along with the name of the tool. So in order to design the tool interfaces, if we talk about some important principles to consider, be explicit, be narrow, be unambiguous, and avoid optional chaos. So whenever you are designing the tool interface, we have to be explicit. Explicit means we have to be very detailed. Everything should be clear. No ambiguity should be there. We have to be narrow. Narrow means the tool, it has to have a very clear purpose. It should not be very generic. So it should have a very clear purpose. Narrow. It should be unambiguous. And we should avoid optional chaos. So the clearer the interface, clearer the interface, the easier the tool selection becomes. The clearer the interface, the easier tool selection becomes. The tool selection, if we talk about, it will become very easy if the interface is very clean. Input validation. So if we talk about input validation, so the idea is that whatever tool we are designing, it will be taking the input parameters. So it should validate the input. That is what input validation is. Because AI agents, they operate in probabilistic environments. AI agents, they operate in probabilistic environments wherein things are uncertain. The environment in itself is uncertain. Because of this uncertainty, because of this probabilistic environment, tool inputs must be validated before execution. Because validation protects against model hallucination. Like if we do the input validation, then we can avoid model hallucination. We can avoid malformed parameters. We can avoid missing required fields, type mismatches, type mismatches, and security vulnerabilities. So now it's very clear that AI agents, they operate in probabilistic environments, and it is a very good practice that whatever input we are sending to the tool, first we should validate. So the tool, it should first validate the input. So validation will protect against hallucination, malformed parameters, missing required fields, type mismatches, security vulnerabilities. Now, how exactly the validation will be done? So if we talk about the validation layer, so the defense, type checking. So validation will be done by type checking. We should check the data types, required fields, range constraints, schema validation, permission checks. So now whenever we are designing the tool, we should have a validation layer in place. And what the validation layer should do, whatever the input it is receiving, we should do the type checking, required fields, range constraints, schema validation, and permission checks. So with this validation layer in place, whatever unsafe input we are getting, this validation layer will filter it, and only the validated inputs, it will send it to the tool for execution. Because of that, now the tool will receive the validated input, the safe input. And when the tool will execute, the tool will automatically avoid or bypass hallucination mistakes, malformed parameters, missing fields, security vulnerabilities, type mismatches. So we should never assume perfect inputs. Rather, tools must defend themselves. Tools must defend themselves. Structured outputs. If we talk about structured outputs, the tools, they should return structured outputs. Tools should return structured outputs. So bad output means refund process successfully. Okay, so see, the idea is that whatever the tool, the response the tool it is generating, it should not be just a message. Rather, it should be a structured output. It should follow a JSON schema. So rather than just sending a message like refund process successfully, we should have a better output like in the JSON format, status success, refund ID. Like these are the parameters, these are the value. So status is the parameter, the value is success. Refund ID is the parameter, the value is R123. Amount is the parameter, 25.99 is the value. Currency is the parameter, USD is the value. So key value pair. So this is the better output because it is a machine readable format. Because if this output is sent to the LLM also, it can interpret it. So now it's very clear that the output generated by the tools has to be structured. So tools should return structured outputs. So it should be a form of a JSON schema, key value pair, which is basically a machine readable format. Structured outputs, it allow structured outputs, it allow reliable downstream reasoning. Okay, so downstream reasoning means, uh, the large language model, it is sending a request to a tool, tool is processing and generating a structured output. Now the large language model, it can further reason looking at the structured output, like what next set of actions it should take. So that is what reliable downstream reasoning is. Structured outputs, it allow logging and monitoring. Like if we can log and monitor all the outputs of tools, so structured output, it allows us to maintain logs and monitoring. It allows conditional logic. It allows conditional logic. It allows UI integration. So the agentic AI systems, they require machine readable responses. So the tools we are designing, it should return structured outputs. It should return machine readable responses. So natural language is for users. So the end users should be provided with the natural language, but structured data is for systems. But for systems, it has to be structured output, no natural language. So here what we are doing is we are separating the concerns for human interaction versus the system automation, tool naming and schema clarity. Now let us look into the tool naming and schema clarity. So tool names, it influences the behavior. So tool naming is very important and schema clarity is very important. So if we talk about tool names, it influences the behavior. So when we are naming the tool, we should use appropriate tool names. So tool names, it should be verb driven. So see, the idea is that the large language model, it will decide which tool to call. So the name of the tool will influence the model behavior. The name of the tool will influence the model behavior. Tool names influences the model behavior. So tool name should be verb driven. Like whatever the intent of that tool, that should be very clear. The purpose of the tool should be very clear. So the tool name should be verb driven. It should be specific. It should be action oriented. It should be consistent. So tool names should be verb driven, specific, action oriented, and consistent. If we look at some examples, good examples of tool names. So cancel order, issue refund, retrieve order status, update account email. So these are good examples of tool names because these names are verb driven, specific, action oriented, and consistent. Like cancel order, issue refund, retrieve order status, update account email. So in every name, the intent is very clear. So that's the key. Clear intent is equal to better model focus. So intent is the key. So clear intent. So if the intent is clear, the model will be, it will be easy for the model to go for a particular tool based on a scenario. Avoid vague names. Avoid vague names. So we should avoid vague names like handle request, execute action, process. So these are some names of the tool. See, handle request is ambiguous. It's vague. What kind of request? Execute action. Once again, it's vague. What kind of action? Process. What process we are talking about? So if we compare the good names with the vague names, if we look at good names, it is very specific. Like cancel order. So we are talking about canceling an order. Issue refund. We are talking about issuing a refund. Retrieve order status. We are talking about retrieving an order status. Update email account. We are talking about updating an email account. So that's a good example. And vague, if we talk about handle request, execute action, process. So it's vague. Schema clarity matters equally. Schema clarity matters equally. So name of the tool is important. Along with that, schema clarity is equally important. So the parameters. So when I talk about schema, I'll be talking about the parameters. The parameters which the tool will take, it should match natural intent. It should use consistent naming, and it should avoid ambiguous fields. So the parameters, it should match the natural intent, it should use consistent naming, and it should avoid ambiguous fields. Ambiguous schema increases the tool misuse. Ambiguous schema increases the tool misuse. So this is tool naming and schema clarity. Tool reliability considerations. Now we will discuss tool reliability considerations. So see, tools, they operate in the real world. Tools operate in the real world. Tools must handle network failures, because let us suppose a tool is trying to communicate or interact with a API, and any network failure occurs. So tools should handle that. So tools operate in the real world. Any failure occurs, tools should handle that. So if network failure occurs, tools, what should they do? They should keep on retrying with exponential backup. It should keep on retrying, establishing connection with exponential backup. Timeouts. So tools can use fixed timeouts or adaptive timeouts. So tools can use either the fixed timeouts or adaptive timeouts that adjust based on current network conditions. That adjust based on current network conditions. Tools must handle partial responses. Now the idea is that a tool can wrap business APIs, and if the business API is generating partial responses, tools should be able to handle it. So tools should be able to handle partial responses. Backend errors. So any error in the backend, like the APIs or any other system call, if any backend error is there, tools must be able to handle it. If the error rate, it exceeds a certain limit, the tool trips a circuit breaker to stop sending requests immediately, giving the backend time to recover. See, the idea is that let us suppose some backend error is there. Now, if the tool will keep on requesting the backend, it might create some very disastrous situation. So there should be a circuit breaker in place wherein the tool can trigger it, so that further request will get stopped and it will give the backend time to recover. And also, whenever any backend error is there, instead of showing a blank screen, we should show some relevant methods, some relevant information we should show rather than just showing a blank screen. The tools, they should also handle like rate limits. Like tools must monitor for too many requests and respect the retry after header if provided. Throttling. The tool can proactively slow down its own request rate to stay within known limits of the service. So the tool can proactively slow down its own request rate to stay within known limits of the service. So now it's very clear that agents, the tools, they operate in the real world. In the real world is very uncertain, and reliability is all about handling the uncertainty. So the tools, they must handle the network failures, they must handle timeouts, partial responses, backend errors, and rate limits. So agent systems must include retry logic, timeout controls, fallback strategies, error propagation rules. Tool reliability determines agent reliability. Because see, the idea is that the agents have to be reliable. For the agents to be reliable, it must include the tools. For the tools to be reliable, it has to include retry logic, timeout controls, fallback strategies, error propagation rules. So tool reliability determines the agent reliability. Unreliable tools, it create cascading failures. Unreliable tools, it creates cascading failures. Designing for safe execution. So if we talk about designing for safe execution, so the idea is that the execution of the tool has to be safe, because the tool execution, if we talk about, it can carry risk. Tool execution can carry risk. For example, if the tool execution involves sending money, deleting records, updating billing info, sending mass emails. If the tool execution involves sending money, deleting records, updating billing info, sending mass emails, these operations carry risk. So tool execution can carry risk. So we have to consider design safety. So design for safety can be incorporated by considering or by including confirmation steps. Like whenever any critical action needs to be performed, confirmation from the user should be taken. So confirmation steps should be included. Human in the loop approval, logging and audit trials. Like whatever the tools, the actions it is performing, we should log it and we should audit the logs. So logging and audit trials. Reversible actions, very important. So reversible actions are the actions which can be undone. So for reversible actions, we can ease the restrictions because actions can be undone. Permission gating. So now it's very clear that for safe execution, some very important design principles we should keep in mind. So whenever you are designing the tools, you should design for safety by including confirmation steps, human in the loop approval, logging and audit trials, reversible actions, and permission gating. Safety principle, if we talk about, automate reversible actions first. So as a safety principle, say reversible actions are less critical because they can be undone. They can be reversed back to its previous state. So first we should automate the reversible actions. Then we should consider high risk execution. So automate reversible actions first and never allow high risk execution without safeguards. Never allow high risk execution without safeguards. So whenever we are talking about high risk execution, we should consider safeguards. Never allow high risk execution without safeguards. Narrow tools versus general tools. So now let us discuss narrow tools versus general tools. If we talk about narrow tools, so as the name suggests, narrow tools, they are focused on some specific task. For example, cancel order. So as the name suggests, this tool is dedicated only to cancel the order. It will just take the order ID and for that order ID, it will cancel the order. So cancel order, it's a very narrow tool because it will perform only a specific task. Now, what are the pros of it? Clear purpose. So narrow tools have clear purpose. They're easy to validate, high reliability, and easier monitoring. Because we know that narrow tools, they are designed for specific purpose. So clear purpose. That's why high reliability, easier monitoring, easy to validate. And if we talk about cons, The drawback is that when we are using narrow tools, we have to use more tools, because for every particular task, we have to have a tool. So the number of tools will increase. In the tool registry, the number of tools will increase. So slightly larger tool registry we will have because of the narrow tools. If we talk about general tools, example of general tools. So see, general tools are the tools which are generic in nature, which can perform multiple tasks. So instead of cancel order, we are creating a tool called modify order. Now this modify order, it can cancel the order, it can issue refund, or it can perform multiple actions based on the action type. So I have designed a tool which can perform multiple actions based on the action type. So based on the type of the action, I will specify this tool will perform multiple actions. So it's a general tool. So modify order is an example of a general tool which will take an order ID, some parameters along with the action type. Action type will decide the type of action which needs to be performed. So modify order can be delete order, place order, issue refund. So that is what modify order is. If we look at the pros of it, fewer tools and more flexible. So see, general tools, since multiple actions can be performed by one tool, we will be needing less number of tools and it will be more flexible. It will be more flexible. But if we talk about the cons of it, the disadvantages, higher ambiguity, higher ambiguity, increased misuse risk, higher ambiguity, increased misuse risk, harder validation, and more complex error handling. See, general tools, since they can perform multiple actions, ambiguity will increase. So higher ambiguity will be there. And since one tool can perform multiple actions, misuse risk is also there. That tool can be misused. Harder validation. The validation will be tough and more complex error handling. So we saw narrow tool and general tool. If we look into some best practice which you should follow, like when you're designing the tool, there will always be a confusion whether you should go for a narrow tool or for a general tool. So this best practice you should follow. So always prefer narrow tool in early systems. Like in early systems, you prefer narrow, well-defined tools. In early systems, you prefer narrow, well-defined tools. And later, once your system evolves, it becomes mature. So complexity increases exponentially with overly general tools. So the drawback of overly general tools is that only complexity increases exponentially. So that's why you should avoid general tools in the beginning. Complexity increases exponentially with overly general tools, and that's why we should prefer narrow tools in the early stages. And later you can combine multiple, like some tools into a single tool, because complexity it increases exponentially with overly general tools. Tool granularity decisions. If we talk about tool granularity decisions, so first let us understand what is the meaning of granularity. So granularity, it defines how specific a tool should be. So granularity, it defines how specific a tool should be. How specific a tool should be. For example, there is always, like, either you can have granular actions like create invoice, send invoice, and cancel invoice. So either you can have granular actions. Granular actions means we are breaking down the actions into more specific actions. So granularity defines how specific a tool should be. So here we have three tools. So create invoice is a tool, a separate tool. Send invoice is a separate tool. Cancel invoice is a separate tool. On the other hand, we can have just a single tool manage invoice, and the action type will be create, send, and cancel. So here I am using only one tool. So I am calling it coarse grained tool. So coarse grained tool is like a single tool, and granular tools means three tools. Every tool is doing a specific action. So that's the idea. So now it's very clear the meaning of tool granularity. So all there is always a confusion whether we should make our tool more and more granular, wherein the tool will be more and more specific, or we should make it general. So the granularity of a tool, it depends on, so tool granularity depends on risk level. So see, for high risk actions like delete database record, send payment, we have to break the tools into granular steps. So it's so based on risk level will decide the granularity. For high risk actions, we have to go for granular tools. We should break it into steps. So for high risk actions, we should consider granular tools. Finer granularity allows agent to pause between critical steps, reducing catastrophic errors. Because with finer granularities, high risk action, we can proceed step by step, and we can reverse the action also. We can avoid or we can reduce the catastrophic errors. Workflow complexity. Workflow complexity. So workflow complexity will also define the granularity level. So for a dynamic workflow, we should use granular tools, because a dynamic workflow means it is automated, and it is uncertain also. So it's always good to have granular tools. So for dynamic workflow, we should consider, we should use granular tools for pivoting. So if a workflow is highly dynamic and depends on real-time reasoning, we should use granular tools so the agent can pivot between steps. But for static workflow, we can consider using coarse grained tool, because we know that the workflow is static. So we can like create a more general tool which can perform multiple actions. So all the sequence of steps, we can integrate it into a one general tool. So we can wrap it in a single general tool, coarse grained tool for static workflow. So granularity, tool granularity, it depends on the risk level, workflow complexity, observability needs. It depends on the observability needs. So granular tools, they provide a clear audit trail. That's very clear also, because when we have granular tools, a very specific observation we can make, like fetch data, format data, process data. So with granular tools, very clear audit trials we can get. We can see exactly which subtool failed. But with general tools, coarse grained tools, it is like a black box tool, because many capabilities are like inside a single tool. Because of that, it will be very tough to have a clear audit trail. Like if any error occurs, it will be very difficult to identify which capability or which set of action was responsible for that error, or why that error occurred. So it is harder to determine if error was in input, processing, or external API. So observability needs also decide the tool granularity. And the fourth important aspect is the scalability. Scalability also decides the tool granularity. So if we talk about reusability, if you want reusability, if you want your tools to be reusable, then we should use granular tools. because small granular tools are the building blocks for dozens of agents and they are very easily reusable. So for reusable tools, you should go for granular tools. And when it comes to maintenance, generic tools are very hard to maintain because generic tools or coarse grain tools, changing one part of a system of a massive multifunction tool might break other unrelated features. So for maintenance also, you should go for granular tools. Granular tools are very easy to maintain because we will be updating in isolation, and any changes we will be making, we'll be doing it in isolation. But in generic tool, coarse grain tool, any particular feature updation we will be doing, that might affect other components of the system of the tool. So maintenance, so with regards to scalability, like the reusability and maintenance, we should consider small granular tools instead of coarse grain tools. So now we saw that tool granularity depends on the risk level. For high risk actions, we should consider the granular tools, narrow tools, specific tools. For dynamic workflows, we should consider the granular tools, and for static workflows, we can go for generic tools. When it comes to observability needs, granular tools will provide us more observability, clear audit trails as compared to coarse grain tools. And when we talk about future scalability, like the reusability and maintenance, we should go for granular tools. So for high risk actions, go for more granular tools. For low risk actions, you can consider moderate consolidation is acceptable. Now we will look at designing capabilities for specific task. Designing capabilities for specific task. When you design capabilities, you aren't just giving the AI access to a database. You are giving it hands to perform specific actions on behalf of the user. So now we will be learning how we can design capabilities for specific tasks. So designing capabilities is not just about giving access to resources or giving access to particular functionality. Designing capabilities means giving hands to perform specific actions on behalf of the user. See, if we talk about traditional API design, it focuses on resources. Traditional API design, it focuses on resources. Like put calendar events 1, 2, 3. So we are accessing a particular resource and adding an event in it. So traditional API design, it focuses on resources, but conversational design, it focuses on outcomes. Move my 2 p.m. to 4 p.m. So, so here what we are doing is that we are telling that whatever was scheduled for 2 p.m., you reschedule it to 4 p.m. So conversational design focuses on outcome, and traditional design, it focuses on resources. So the idea is that whenever we are designing capabilities, intent is the key. Intent is the key. Like the clear purpose, the goal which we want to accomplish. So tools should map directly to user intents. Tools should map directly to user intents. So, so we should ask, what does the user want to accomplish, and not what endpoints exist. So this is very, very important. So now the idea is very clear. When we are talking about designing capabilities, the main point is the intent, user intent, what the user want to achieve, the goal. So whenever we are designing any capability, we should ask that what the user want to accomplish. What does the user want to accomplish? This should be our question, and not what endpoints exist. We should not care about endpoints. So once the intent is clear, for that intent we should design a tool, and that tool in the background it should wrap the APIs which will help in accomplishing the intent of that tool. So this is how the capabilities should be designed. So now it's very clear that whenever we are designing a tool, we should ask the question, what does the user want to accomplish using this tool, or what the user want to accomplish. So the intent we got, user intent we got, then we have to design a tool for that user intent, and in that tool we should give it a name, the parameters it will take, the description, and we should wrap APIs which will help in accomplishing the user goal, the intent. So let us look at an example. So the user intent is reschedule my meeting. Reschedule my meeting. So this is what the user want. User wants the goal the user want to accomplish is reschedule my meeting. So for this user intent, we can design a tool. So the tool should be reschedule meeting, meeting ID, and the new time. And this tool should make use of the calendar API. And when we are designing the tool, the name of the tool, the parameters, they play a role. So if you design a tool like this, update calendar entry metadata blob, this is inappropriate. So we should have a tool with a clear name, verb driven, action oriented, with clear parameters. So we should design the tool or design the capabilities for intent clarity. So intent clarity is the key. So now we will look at tool design anti-patterns. Tool design anti-patterns. Like when we are designing the tools, some anti-patterns we should avoid. So we should avoid using tool names that exposes backend internals. Like we should not use a tool name called DB query raw SQL. We should avoid overloaded tools with too many optional parameters. Like we should not have too many optional parameters, like one mega tool with 20 plus arguments. It's a bad practice. We should avoid that. We should avoid free text parameter fields without schema. So we should avoid giving free text parameter fields without schema, like unstructured prompt string input. It can be dangerous. We should avoid tools that return only natural language. We should avoid tools that return only natural language. So we already saw that the tools should return structured output in machine readable format. So structured data, JSON output it should be. So we should avoid using the tools that return only natural language. We should avoid using tools without input validation. Input validation is very important. Input validation can safeguard from model hallucination and many more things. So missing type checks, range validation, we should avoid that. And we should avoid no logging. So each and everything should be logged. So we should keep a track of silent failures. We should do audit trails. So we should avoid no logging, because no logging will lead to silent failures, no audit trail. So these anti-patterns are very dangerous. These anti-patterns, they create brittle agents, and brittle agents are those which can very easily break down. In the real world, brittle agents are not flexible. They cannot handle the uncertainty. They are not reliable. They can easily break down and the system may collapse. So the bigger picture is tools are the execution layer, the action interface, and the bridge to infrastructure. Because if we talk about tools, tools are the one which will be taking care of the execution layer, the action interface, and the bridge to the infrastructure. So agent maturity is directly proportional to the tool design quality. So tool design quality will decide the agent maturity. So tool design quality is very important. If your tools are poorly designed, no model upgrade will save you. If your tools are poorly designed, no model upgrade will save you. So we have to pay special attention on tool design, the quality of the tool design quality. So finally, we completed this lecture. So in this lecture, we saw what tools are in agent systems, how to convert APIs into agent-friendly tools, why interface design matters, the importance of input validation, why structured outputs are essential, how naming clarity reduces the ambiguity, reliability and safety design principles, narrow versus general tool trade-offs, and tool granularity strategy. So very important tool design quality aspects we discussed. I hope you got very good understanding of the concepts that we covered in this lecture. So do subscribe to this YouTube channel ScaleUp University for more such interesting lectures and courses. Thanks for watching. Thanks for your time.